So I'm going to start from chapter 5, but you already know that we have started chapter 5 before this kind of vacations or whatever. But I'm going to start again from chapter 5, so in this way you can also revise a bit. The book you already know what book I am following, that the Fundamental of Light Sources and Laser by Csele. So what we have studied in the previous chapter, that there are three basic parts if you want to generate a laser. So these parts like lasing medium, cavity and pump source. ये चीज़ पहले पढ़ चुके हैं. Like if you have, this is your pump source, this is a laser medium, cavity, and here you have pump source. So in this lecture, first we are going to discuss about selective pumping. We should have proper pumping source. और ये pumping source जो है ये आपका, it should match the absorption band of the lasing medium. What do you see here in this figure? That this is absorption band of YAG crystal or YAG laser, you can say. So as you know, we already studied that one of the important solid state laser is the YAG laser. So what do you see here in this the figure? The region around from 750 to 800 nanometer, which is the most important part. So if we have a pump which can exactly match, emit the light in this region, then we can say that this pumping source is suitable for YAG laser. So whenever we decide the pump source, then we should have in our mind, or we should know about the absorption band. Here one of the example of the YAG laser, and we already know that there are a number of solid state lasers and number of gas lasers. Mostly the pump source what we use for the solid state laser is flash lamp. Okay, the flash lamp filled with inert gases. In the next slide we will see, some flash lamp pumping sources. But here the important thing to understand is absorption band. We have to know the absorption band of specific laser or specific laser crystal or rod or gas laser as well, or any other kind of laser. So we have to study the absorption band, then we decide accordingly what kind of pump source we can use. As you know already, the optical pumping or electrical discharge pumping, or it can be we can also use the solar light as a pump source. And for the solid state, mostly we use optical pump source. So that can be in the form of flash lamp or can be in the form of another laser. तो ये मैं जो कहना चाह रहा हूँ मैं यहाँ पे इट्स लाइक कि हमें एक प्रॉपर पंप सोर्स जो है वो चूज़ करना होता है फॉर अ पर्टिकुलर लेज़र के अकॉर्डिंग टू द एब्जॉर्प्शन बैंड. और यहाँ पे जो एब्जॉर्प्शन बैंड है याग लेज़र का वो 750 से 800 नैनोमीटर. तो अगर हम जो सोर्स है दैट वी कैन जो हम सोर्स फाइंड आउट करें वो जो लाइट इमिट करे इस रेंज में, वो इसके लिए जो है वो सूटेबल होगा. नाउ लेट्स मूव टू द नेक्स्ट स्लाइड. There are a number of flash lamps, but mostly we use inert gas flash lamps like xenon lamp, krypton lamps. They have different, spectrum, even though they are emitting the light, which we generally can call that is white light. Here you can see the spectrum. This is a krypton lamp and this is xenon lamp. And this is the spectrum of these two lamps. Okay, so the wavelength versus absorption radiance. तो यहाँ पे आप देख सकते हैं कि ये जो क्रिप्टॉन लैंप है that is 0.8 to 0.9, so it's in the IR region. So the IR region is very much suitable to pump the YAG laser, as we have seen in the last slide. Or so trap-top lamp is a good source to pump the YAG laser. On the other hand, xenon lamp. So xenon lamp, what do you see here? कि xenon lamp का जो strong region है is from something around 500 nanometer to onward. It can go up to 600 nanometers. So blue, green, or something this region may that can operate this xenon lamp, even though you can see it's a white light, but this region is strongest. So it means if we use xenon lamp as a pump source, for the YAG laser, so it will not work efficiently because it's not matching with the absorption band of the YAG laser. On the other hand, as we have already studied the ruby laser, तो जो रूबी लेजर का जो absorption band है वो it's like yellow and green region. So it means the xenon lamp is very much suitable to pump the ruby laser. So xenon lamp is very much suitable to pump the ruby laser, and krypton lamp is very much suitable to pump the YAG laser. The reason is that the absorption band. The absorption band of the YAG laser, the absorption band of the YAG laser in the infrared region from 752 onward, and that is why krypton lamp is very much suitable. And on the other hand, the absorption band of the ruby in the yellow-green region. So this xenon lamp is very much suitable because starting from 500 or nanometer to onward. Okay, so this is how we have to see the possibility that how to choose the pump laser. तो मैंने यहाँ पे क्या एक्सप्लेन किया है कि तो अब्जॉर्प्शन बैंड जो है पहले उसको स्टडी करते हैं, फिर उसके मुताबिक हम जो है वो फ्लैश लैम्प सोर्स जो पंप सोर्स है वो हम डिसाइड करते हैं। तो यहाँ पे दोनों स्पेक्ट्रम दिखाए गए हैं, वो जीनॉन के और क्रेप्टॉन के। तो ये दोनों जो स्पेक्ट्रम हैं आपको फ़र्क नज़र आएगा कि इसमें एक पीक नज़र आ रही है जो कि अराउंड 800 नैनोमीटर है, यहाँ पे एक पीक नज़र आ रही है जो अराउंड 500 नैनोमीटर है। और हम पिछली स्लाइड में हमने देखा था कि जो अब्जॉर्प्शन बैंड है याग का वो इंफ्रारेड रीजन में 750 एंड ऑनवर्ड आता है, तो उसके लिए क्रेप्टॉन लैम्प इज़ वेरी मच सूटेबल। ठीक है, और फिर उसके बाद जो जीनॉन लैम्प आया वो रूबी के लिए इसलिए सूटेबल है कि रूबी का जो अब्जॉर्प्शन बैंड है वो येलो ग्रीन रीजन में आता है और इसकी पीक जो है वो 500 नैनोमीटर ओके, अराउंड ग्रीन और समथिंग लाइक दिस। सो ये इसलिए जो है पंप सोर्स जो है वो हम प्रॉपरली डिसाइड करते हैं ऑन द बेसिस ऑफ जो है आपके पास absorption band of the laser. Now let's move to the next slide. We have already discussed this 3 and 4 level lasers in the previous chapter a little bit. If we want to understand the laser, then we categorize the laser that it's a 3 level laser and these are 4 level laser. These are basically energy levels. If you see here in the three level laser here and 4 level here, so this is the 3 level laser and this is the 4 level laser. What is happening in a 3 level laser that this is a ground level, okay, this is the ULL upper lasing level and this is the pump level, and this one is showing the lasing. So ground level, upper lasing level and pump level. So first we pump it using any pumping source, okay, so excite the atom. So when you excite it, and this is it shows the excitation, okay, and after that excitation it decay to the ULL, okay, upper lasing level. ये decay जो है it generates heat, okay, not the light, okay. So from pump level to ULL, when it decays from pump level to ULL, it generates heat, okay. At ULL it stays for a while, okay, it depends on the lifetime. It stays for a while to develop the population inversion. The population inversion, what is population inversion, which we have studied already in the last chapter, okay. So number of electrons is more here as compared to ground or as compared to the other level, which we can call here like low energy, low lasing level, okay. So pump से ULL, it decays to the to ULL, heat is generated, and after that it stay here at ULL and then further decay to the ground by emitting the photons, okay, that is in the form of laser, okay. So the thing is that the population inversion is developed here, okay, and more electrons are gathered here as compared to here, and that is why the lasing happened. This is what happening in the 3-level laser, okay. In the 3-level laser, one of the thing that there is no another intermediate level here, so it directly goes to the ground, okay, which is a natural state, and from the ground you need to pump again, so you need too much energy for the pumping. So that is why the 3-level laser mostly they are as I mentioned before, I mean in my lectures, that the pulse laser and CW laser. The pulse laser are usually 3-level laser, and CW laser are usually 4-level lasers. The reason, as I mentioned, that it needs a lot of energy to pump again, okay, and to start the process. On the other hand, the 4-level laser here, you have 4-level laser here, okay, you excite by pumping. This is the pump level, and decays to the ULL, upper lasing level, and then from upper lasing level it decays to the lower lasing level. So it's obvious to create the population inversion, the lifetime here is more of this level, lifetime, as compared to this. So electron gathered here, okay, number of electrons are more here as compared to there, so that is to satisfy the condition of population inversion. So from here it decays to LLL, and it emits the photons, it emits the photon in the form of a laser. And further from LLL, lower lasing level, it after a while it decays to the ground, okay. So that is why as compared to 3-level laser, 4-level laser, you don't need very high energy, or so this is one of the reasons. So you can operate it continuously. So what I explained here, कि जो लेज़र को 2 कैटेगरी में डिवाइड किया जाता है, 3-level लेज़र होती है और एक 4-level लेज़र। 3-level लेज़र में आपके पास जो है 3 एनर्जी लेवल होते हैं, और 4-level लेज़र में आपके पास 4 एनर्जी लेवल होते हैं। और यहाँ से जैसे कि आप देख सकते हैं 3-level लेज़र में ग्राउंड लेवल है, ये पंप लेवल है, ये अपर लेजिंग लेवल है, और जब हम एक्साइट करते हैं तो एटम जो है वो डिके होता है, तो इलेक्ट्रॉन कुछ देर के लिए ULL पे ठहरते हैं, अपर लेजिंग लेवल पे, पॉपुलेशन इन्वर्जन बनती है, और उसके बाद वो ग्राउंड पे आते हैं, वो एंड देन जो इमिट करते हैं फोटोन, वो इन द फॉर्म ऑफ लेजिंग। और यहाँ पे क्या होता है कि एक्साइट जब करते हैं पंप, तो वो डिके करता है ULL पे, और ULL से फिर LL की तरफ जाता है। ULL पे कुछ देर ठहरते हैं, पॉपुलेशन इन्वर्जन होती है, और उसके बाद आपकी लेजिंग होती है, और LL पे कुछ देर, और उसके बाद अल्टीमेटली जो है वो ग्राउंड लेवल पे चले जाते हैं। कुछ पॉइंट मैंने यहाँ पे मेंशन किए हुए हैं, that which I explained actually already, or this will also help you to understand more. Though the famous 3-level laser, the solid state laser especially, I would like to say, is ruby laser. और जो मोस्टली हम जो सॉलिड स्टेट लेज़र आजकल भी यूज़ करते हैं वो याग लेज़र, that is 4 level laser. One of the example, I mean, you can say that is 4 level laser. Now let's move to the next slide. There are some of the, I mean, important points which I am repeating again here. The thing is, we just studied that there are two kinds of, I mean, categorized in two types: 3 level laser and 4 level laser. So some important points are mentioned here. You can see the output of the laser can begin as soon as population inversion occur. As soon as you achieve the population inversion, number of electrons more at ULL, उसके साथ ही जो लेजिंग आपकी स्टार्ट हो जाती है. Okay, and we already know what is stimulated emission. Gain increases until it exceeds total losses in the system. Okay, in the last chapter we studied about the gain. So gain should overcome the losses in the lasing medium, okay, in the overall laser system. So that's what is mentioned here. Gain increases until it exceeds the total losses, to overcome the losses, okay, to overcome the losses. Third thing mentioned here, that in a 3 level laser it takes a large amount of pump energy to generate an inversion, as I mentioned, because there is no intermediate level like LLL. So it needs a large amount of energy. Okay, so that is why it's pumped in the form of a pulse. Okay, because too much heat is generated. I mean, you have to, compensate this heat. Okay, you have to dissipate this heat in some way. So the reason is here that since the population of the ULL must exceed that of the ground state, this is the population inversion. And in 4 level laser, that inversion जो है population inversion, we can achieve this population inversion with much lower pump energies, because the reason, as I told you, that LLL, lower lasing level. Okay, so this LLA is discrete level. Okay, and that is not populated to nearly the level of the ground state, because ground state is a natural state. All the atoms gather at the ground. So this LL is not a ground state. Okay, so that is why you don't need very high pump energy in case of 4 level laser. Okay, so these are some important points जो मैंने यहाँ पे explain किए. And in my next lecture I will move further. The upcoming slide you will see what we will discuss. Definitely I'm following the chapter 5.